Hello everyone, I'm glad to have the opportunity to share some experiences about data-driven power dispatch technologies in Jibei power grid of China. The State Grid Corporation of China, we say SGCC, the core business of which is to build and operate power grids in China. The service area, at the blue part of the map, covers 26 provinces and takes 88% of China's territory. By the end of 2020, the total installed capacity had reached 1,700 gigawatts. The renewable energy, especially wind and solar power capacity, increased fast in the past few years, and exceeded 230 gigawatts and 220 gigawatts respectively. By now, China has the largest wind and solar power all over the world. As one provincial power company of SGCC, Jibei provides electric power to 5 cities in North Hebei province. It is the first provincial power grid with more renewable than thermal generations. The wind and solar power capacity had reached 19.5 gigawatts and 8.7 gigawatts by the end of 2020, and 88% of renewables are located in 2 cities, Zhangjiakou and Chengde, in which the accommodation capabilities of renewables are very limited due to weak power networks. During the past decade, the Jibei Power Company had accumulated a large amount of operating data, so we used data-driven dispatching technologies to improve renewable energy accommodation. Supporting technologies include monitoring, forecasting, schedule optimizing, and power controlling. The first is monitoring. Real-time operational data, including wind turbine power, wind speed, operational status, are transmitted to the dispatching center. These data are used to calculate the effective capacity of wind farms for better scheduling. I will introduce the remote telemetry and signal data briefly. Typically, for the wind turbine, we selected several measuring data, including real power, reactive power, and nacelle wind speed. Particularly, data integrity of wind speed is a key factor, which influences the calculation of theoretical power. The signal data can be divided into 2 categories, operating and shutdown. Then, we divided each signal into different subcategories, such as generation, deregulated generation, scheduled maintenance, non-planned outage, and so on. The component analysis of energy curtailment is based on high-quality operation information of each wind turbine and PV inverter. Let's go to the basic principle of whole process assessment. The accommodation level of renewable generation is determined by many factors, such as wind and solar resources, equipment reliability, grid operation constraints, and priority dispatching. The purpose of whole process assessment is to analyze the influence of each factor quantitatively. Here, we give an example of wind power accommodation assessment. First, we evaluate wind resource and theoretical wind power based on nacelle wind speed. Theoretically, the real wind power generation will equal to the theoretical generation. However, in real operation, we found that the real generation is only 82% of theoretical generation. That is to say, 18% of the wind energy is curtailed. We divided the curtailment into 2 categories, interplant curtailment and outer plant curtailment. Many inner plant factors can result in wind energy curtailment, such as the wind turbine maintenance, fault, and outage of inner plant equipment. On the other hand, the maintenance and outage of transmission lines, the interface limit, and the peak valley limit can lead to the outer plant curtailment of wind energy. The calculation process of the nacelle wind speed method is as follows. Firstly, we use actual operation data to establish the mapping relationship between active wind power and nacelle wind speed for each turbine. Second, when curtailment occurs, the wind turbine is generation deregulated or even shut down due to the dispatching instruction. Based on the actual measured wind speed and the power curve, we can get the theoretical wind power. Finally, we integrate the power curve to get the theoretical generation during one period. Based on the massive data of renewable energy, the full spectrum of the influencing factors of renewable energy curtailment is presented, and the impacts of resource, equipment, schedule on renewable energy accommodation level are accurately evaluated. And the bottleneck, which influences the accommodation level, is accurately detected. Second, let's go to power forecasting. We found that power forecasting results were too conservative for extreme weather, for example, gale weather. The predicted wind speed is usually larger than the real value near the cut-in speed, and smaller near the cut-out speed. Based on the statistics of numerical weather forecast deviation and anemometer tower data, correction model of gale weather is constructed, which can improve prediction accuracy of power generation. When the environmental temperature is below -30 centigrade, wind turbine will switch off due to low temperature protection, while the current power forecasting systems do not consider the influence of low temperature. Based on the historical temperature-capacity relationship curve, wind power forecast will be corrected if low temperature is predicted. Traditionally, the day-ahead power generation scheduling is made only once a day, which results in inaccurate power generation plan due to the poor prediction accuracy. Here, we adopt the dynamic optimization method of power generation plan. The forecasting results are corrected by the numerical weather prediction initial fields every 6 hours, and the model output statistics method is used each hour to improve the accuracy of the short-term prediction. When the power prediction deviations are greater than a certain threshold, the last prediction result is used to dynamically correct the day-ahead power generation scheduling in order to enhance system accommodation level for renewable energy. In order to maximize the accommodation of renewable energy, a hierarchical and coordinated active power control strategy for renewable energy is used, which considers the peak shaving capacity, the maximum utilization of transmission channels, and the balance of wind and solar power. Based on the ultra short-term power prediction for each wind and solar power plants, and the differences between power generation instructions and actual power output. The wind and solar power plants are grouped. We calculate the power generation capability and the instructions for each group in real time to allocate transmission capacity. At last, the intermittency and uncertainty of renewable energy have brought great challenges to the whole process of grid dispatching and operation. Multi-time scale dispatching technologies, such as unit commitment, power generation scheduling, and active and reactive power control are all need to be improved based on massive operational data. In the future, more data will be used to assist grid dispatchers, including climate and weather, power markets, heating monitoring, air quality, and so on, to further improve the level of renewable energy accommodation. That's all. Thank you for your attention.